Novaya Zemlya, October 30th, 1961. A modified Tupolev-2 95 bomber sits on the runway at Olenya Airfield. Its bomb bay doors have been removed. Its internal fuel tanks have been stripped out. The fuselage has been repainted entirely in white, not for identification, but because the engineers calculated that white paint would reflect enough thermal radiation to give the crew an additional fraction of a second before the aircraft's skin began to burn. 9 men climb aboard. The aircraft commander, Major Andrei Sakharov, has been told by Soviet military engineers that he and his crew have a 50% chance of surviving the mission. He takes off anyway. Suspended in the stripped bomb bay, attached to a parachute system weighing 800 kilograms, is a device 8 meters long and 2.1 meters in diameter. It weighs 27 tons. It is so large that the aircraft had to be physically reconstructed around it. It is so heavy, it accounts for 15% of the total weight of the plane carrying it. It has no official name yet. The engineers call it Product 602. The crew calls it Ivan. In the West, they will eventually call it Tsar Bomba, the Emperor of Bombs. What happens next will be the largest human-made explosion in the history of this planet. It will not be matched before or since. This is its story. By 1961, the Soviet Union was losing the nuclear arms race on paper. The United States Strategic Air Command had positioned nuclear-capable bombers across Europe, in the United Kingdom, in Japan, and on aircraft carriers within striking distance of Soviet territory. American medium-range ballistic missiles were stationed in Turkey. The American nuclear arsenal dwarfed the Soviet one in quantity, in delivery systems, and in the ability to reach targets inside the USSR. Nikita Khrushchev understood this. His military commanders understood this. The core problem was simple and terrifying. If the United States chose to strike first in a nuclear exchange, the Soviet Union might not survive long enough to respond. What the Soviet Union lacked in numbers, Khrushchev decided it would compensate for in raw, undeniable, psychologically devastating magnitude. If the Americans had more weapons, the USSR would build one weapon that made quantity irrelevant. On July 10, 1961, Khrushchev summoned the lead physicists of KB-11, the Soviet Union's primary nuclear weapons design bureau, to a meeting at the Central Committee of the Communist Party. His instruction was direct, design and test a thermonuclear device of 100 megatons, not a weapon intended for deployment. A demonstration, a message, something that would make the entire world stop and reconsider whether provoking the Soviet Union was rational. The physicists had 14 weeks. The lead designer was Andrei Sakharov, then 40 years old, already the most decorated physicist in Soviet history. Sakarov had designed the Soviet Union's first true thermonuclear weapon, the RDS-37, tested in 1955. He understood better than anyone alive in the USSR what a device of this magnitude would require and what it would do. Working alongside him were Viktor Adamski, Yuri Babayev, Yuri Smirnov, and Yuri Trutnev. Trutnev and Babayev specifically developed the second and third stage thermonuclear configurations that made the bomb's enormous yield physically possible. The design bureau they worked in was Alzheimer's 16, a closed city that did not appear on Soviet maps. It had no public name. Citizens who lived and worked there were not permitted to discuss its existence. Letters were addressed to a postbox number in Moscow. The city was surrounded by 2 rings of barbed wire fence and a permanent military garrison. Inside Alzheimer's 16, Sakarov's team worked on a 3-stage thermonuclear design. The physics involved were, at that point, at the absolute limit of what human beings understood about nuclear reactions. A standard 2-stage hydrogen bomb uses a fission primary, a conventional nuclear explosion, to compress and ignite a thermonuclear secondary stage. Tsar Bomba added a 3rd stage. The secondary explosion would compress and trigger a much larger additional thermonuclear module. Each stage amplified the previous one. The energy release was not additive, it was multiplicative. The design Sakarov submitted had a theoretical yield of 100 megatons of TNT, 10 times the total explosive energy of every bomb, every artillery shell, every rocket, every mine used by every nation in the entirety of World War II combined. There was a problem. A detonation of 100 megatons would produce radioactive fallout of such magnitude that most of it would descend on Soviet territory. The contamination would be catastrophic. Additionally, the aircraft delivering the bomb would have no realistic chance of surviving. The shockwave would reach the escape aircraft before it could clear the minimum safe distance. Sakarov proposed a modification. Replace the uranium-238 tamper in the tertiary stage with lead, a non-fissioning material. This would eliminate the fast fission reaction in the outer shell, cutting the yield in half to 50 megatons and reducing radioactive fallout to 3% of what the full design would produce. 50 megatons, 3,800 times the destructive power of the bomb that destroyed Hiroshima. More than 10 times all the conventional explosives of World War II. The most powerful weapon ever designed. And they had built a reduced version of it on purpose, because the full design was considered too dangerous to test. The bomb was 8 meters long, 2.1 meters in diameter, 27 tons. No aircraft in the Soviet inventory could carry it as designed. The Tupolev Tu-95, the USSR's primary strategic bomber, required complete physical reconstruction. The bomb bay doors were removed entirely. The internal fuel tanks were stripped out, reducing the aircraft's range significantly. The existing bomb holder was replaced with a new, purpose-built heavy beam mounting attached directly to the structural load-bearing beams of the aircraft's fuselage. This was not a modification to allow the bomb to hang from the plane. It was a reconstruction of the aircraft around the bomb. The specific aircraft selected was Tu-95 volts, tail number 58030302. It had been used for years as a training aircraft after the test was originally postponed in 1958 for political reasons. Khrushchev did not want to test a weapon of this magnitude during a period when he was attempting diplomatic engagement with the United States. When the test was reinstated in 1961, the aircraft was pulled from the training program. The exterior of the entire aircraft was repainted in anti-flash white, a specialized reflective coating developed to deflect thermal radiation. It would not protect the crew. The engineers calculated it might help the airframe survive long enough for the aircraft to land. A second aircraft, a Tupolev Tu-16, was assigned as an observer and camera platform. It too was repainted white. It too would carry a crew who had been told their survival was not guaranteed. The single most critical engineering problem was not the bomb, it was time. At the altitude the Tu-95V would fly, 10,500 meters, and at the aircraft's maximum speed of 925 kilometers per hour, the crew had a specific window between releasing the bomb and the moment of detonation to put distance between themselves and the explosion. The bomb would fall toward its target altitude of 4,000 meters above the ground. The aircraft needed to be at least 45 kilometers away when it detonated. At maximum speed, the Tu-95V could cover approximately 4 kilometers per minute. At the moment of release, the aircraft would have approximately 3 minutes and 15 seconds. It was not enough. The solution was a parachute, a single 1,600 square meter drogue parachute weighing 800 kilograms by itself, was attached to the bomb casing. Its purpose was not to soften the landing. There would be no landing. Its purpose was to slow the bomb's descent to the point where the aircraft could gain sufficient distance. The parachute system was designed to deploy immediately on release. It would slow the bomb from a standard terminal velocity to a fraction of that speed, extending the fall time from seconds to nearly 3 minutes. This gave Dernovtsev and his crew their margin. By the time the bomb detonated at 4,200 meters above the ground, the Tu-95 volts had reached a distance of 39 kilometers from the blast point. The Tu-16 observer aircraft was 53 kilometers away. It was barely enough. October 30th, 1961, 11:32 Moscow time. The bomb releases from the aircraft over Mityushika Bay on the Novaya Zemlya test range. The 800-kilogram parachute deploys immediately. The bomb descends slowly relative to the aircraft above it. At 4,200 meters above sea level, 4,000 meters above the surface of the test target, the barometric sensor triggers detonation. The fission primary fires. The energy pulse compresses the secondary stages. The secondary stages ignite and compress the tertiary module. The thermonuclear reaction in the third stage produces neutrons that would, in the full uranium design, have initiated fast fission in the outer tamper. The lead tamper absorbs the neutrons instead. The explosion stops at 50 megatons. What follows is not a conventional explosion in any sense that the word explosion normally suggests. The fireball reaches a diameter of 8 kilometers. It rises at a rate that causes it to nearly reach the altitude of the aircraft that dropped it, the aircraft that had been flying away at maximum speed for 3 minutes. The fireball was visible from a distance of 1,000 kilometers. It was observed by Norwegian border stations, by Greenland, by monitoring equipment in Alaska. The mushroom cloud rises to 67 kilometers altitude, 8 times the height of Mount Everest. It punches through the stratosphere and into the mesosphere. Its top tier spreads to a diameter of 95 kilometers. Its base is 40 kilometers wide. The shockwave from the detonation travels outward at supersonic speed. It reaches the Tu-95V at a distance of 115 kilometers from ground zero. The aircraft is thrown violently upward and then drops 800 meters in altitude in a fraction of a second as the pressure wave passes, and the air density behind it collapses. The aircraft speed jumps from 880 to 980 kilometers per hour in an instant. Dernovtsev wrestles the bomber back under control. The aircraft's external surfaces have been scorched black by thermal radiation despite the reflective paint. The internal structure, the stringers, ribs, and frames of the wings and fuselage, has been compressed by the shockwave hard enough that these internal components become visible through the aircraft's outer skin. The Tu-95V lands safely at the recovery airfield. The crew is alive. Their 50% chance came through. The Tu-16 observer aircraft, 53 kilometers away, is also damaged. Its crew is also alive. The shockwave generated by the detonation circled the Earth 3 times. The first circuit took 36 hours and 27 minutes. A seismic wave in the Earth's crust also circled the globe 3 times. Atmospheric pressure sensors in Wellington, New Zealand, on the opposite side of the planet, recorded 3 separate pressure pulses. The first arrived from the northwest. The second, the same wave returning, arrived from the southeast. The third arrived from the northwest again. Windows shattered in the village of Dixon, 780 kilometers from the detonation point. The heat from the explosion was sufficient to cause third-degree burns at a distance of 100 kilometers from ground zero. A Soviet military observer wearing dark protective goggles felt the thermal pulse at 270 kilometers distance. Atmospheric ionization from the detonation disrupted radio communications across hundreds of kilometers for 40 minutes. The village of Seveny, 55 kilometers from the test site, was completely destroyed. Every structure, wooden and brick alike, was leveled. Stone buildings at greater distances lost roofs, windows and doors. Windows were broken at distances of up to 900 kilometers. At a detonation altitude of 4,000 meters above a city center, the fireball alone, 8 kilometers in diameter, would incinerate everything within its radius. Instantly, no warning, no survival. At 35 kilometers from the detonation point, the overpressure of the shockwave would be sufficient to destroy reinforced concrete structures, not damage, destroy. At 100 kilometers, the thermal pulse would cause third-degree burns to any unprotected skin exposed to the open air. No city in Western Europe is larger than 100 kilometers across. The entire urban area of London, including all suburbs, fits within 60 kilometers of its center. Greater New York, including all boroughs and immediate surrounding areas, fits within 50. Moscow itself, the city Khrushchev was defending with this weapon, fits within 70. A single Tsar Bomba, detonated at the correct altitude above any major city on Earth, would end that city, not damage it, not destroy its center, end it entirely. The weapon was never deployed. It was never intended to be. The design was too large for any intercontinental ballistic missile in the Soviet inventory. The Tu-95V had to sacrifice its own fuel tanks to carry it, limiting its combat range to a fraction of what would be needed for an actual strike mission. And the crew, as the engineers had calculated and told them directly, had only a coin-flip chance of surviving even a test detonation. It was a message, the largest, most violent, most technically demanding message in the history of armed conflict. If you are finding this examination of Soviet weapons engineering of interest, subscribing to the channel helps ensure you do not miss the next one. Andrei Sakharov received the Hero of Socialist Labour Award for the 3rd time after the Tsar Bomba test. He was 40 years old. He had now designed the 2 most destructive weapons in human history, Something changed in him immediately after the test. In his published memoirs, Sakarov described what he felt standing in the closed facility at Arzamas 16 as the monitoring data came in from Novaya Zemlya. The blast had performed exactly as his calculations predicted. The weapon worked. The numbers matched. He felt no triumph. What he felt was responsibility, an awareness of what he and his colleagues had demonstrated was physically possible, not just for the Soviet Union, for any nation that eventually developed thermonuclear weapons at scale. The test had proved, beyond any remaining scientific doubt, that there was no upper limit on the explosive power of a thermonuclear device. No physical barrier preventing the construction of something larger. No ceiling. The same year, at a dinner in Moscow attended by senior Soviet military officials, Sakharov raised a toast. He proposed that the scientists who had built these weapons should never be asked to test them in real warfare. One of the generals present informed Sakharov, with clear irritation, that scientists should not attempt to dictate policy to military men. Sakharov sat down and said nothing further. Over the following years, he began to speak publicly against nuclear proliferation. He became the most prominent Soviet voice calling for arms limitations agreements. He played a significant role in the negotiations that led to the 1963 Partial Test Ban Treaty, which ended atmospheric nuclear testing. He was nominated for the Nobel Peace Prize in 1973. He received it in 1975. The Soviet government refused to allow him to leave the country to collect it. His wife, Yelena Bonner, read his acceptance speech in Oslo in his absence. In 1980, he was exiled to the closed city of Gorky. He lived under KGB surveillance for 6 years. He was released in 1986. The man who built the Tsar Bomba spent the second half of his life trying to undo what the first half had made possible. The political impact of the test was immediate and global. United States politicians condemned it within hours. The Swedish Prime Minister stated publicly that the test was the Soviet answer to a personal appeal he had sent Khrushchev the previous week, asking him to halt nuclear testing. The British Foreign Office issued a statement. The Danish and Norwegian Prime Ministers both issued formal condemnations. The White House described the purpose of the test as the deliberate creation of fright and panic. They were not wrong. Within 2 years, the Partial Test Ban Treaty was signed. The Soviet Union, the United States, and the United Kingdom agreed to prohibit nuclear weapons tests in the atmosphere, in space, and underwater. Only underground testing was permitted. The treaty was directly accelerated by the Tsar Bomba test and the global reaction to it. The bomb itself was never reproduced. Exactly one complete weapon was built. Its design was never adapted for an intercontinental ballistic missile. The single example ever built was used once on a frozen Arctic island to send a message. The Tu-95 volts, the aircraft that delivered it, was donated after the test as a visual exhibit of nuclear blast effects. Its compressed and scorched airframe was used to show students what a nuclear shockwave at 115 kilometers distance does to an aircraft made of aluminium alloy and steel, type 3-stage thermonuclear aerial bomb designed at KB-11, Arzamas 16. Development period 14 weeks. July 1961 to October 1961. Length 8 meters. Diameter 2.1 meters. Weight 27,000 kilograms. Parachute system weight 800 kilograms. Parachute surface area 1,600 square meters. Delivery aircraft Tupolev-2 95 volts. Bomb bay doors removed. Internal fuel tanks removed. Outer skin repainted in anti-flash white. Release altitude 10,500 meters. Detonation altitude 4,200 meters. Detonation time 11:32 Moscow time, October 30th, 1961. Yield 50 megatons of TNT equivalent. Full design yield estimated 100 megatons. Yield reduction method. Uranium-238 tamper replaced with lead. Percentage of yield from fission. 3% percentage of yield from thermonuclear fusion. 97%. Hiroshima bomb 15 kilotons. Tsar Bomba was 3,333 times more powerful. Castle Bravo, the largest American nuclear test. 15 megatons. Tsar Bomba was 3.3 times more powerful. Total explosive energy used in all of World War II by all nations, approximately 3 megatons. Tsar Bomba exceeded this by a factor of 16. Fireball diameter, 8 kilometers. Mushroom cloud altitude, 67 kilometers. Mushroom cloud upper tier diameter, 95 kilometers. Shockwave circuits of Earth, 3. Visible distance, 1,000 kilometers. Third degree burn radius, 100 kilometers. Window breakage radius, 900 kilometers. Radio disruption duration, 40 minutes. Total units manufactured, 1. Major Andrei Sakharov landed his aircraft safely at the recovery airfield. He and his crew were awarded the title Hero of the Soviet Union. The order was signed the same day. The 27-ton weapon that had reduced their survival probability to a coin flip was gone. It had converted itself entirely into energy in a fraction of a millisecond. Its atoms had been redistributed across the Arctic atmosphere. In the West, no one had heard it. The shockwave takes time. The first confirmation reached American monitoring stations as a seismic signal, a magnitude 5.0 to 5.25 earthquake at coordinates corresponding to an Arctic island that the Soviets did not officially acknowledge using for nuclear tests. Khrushchev announced the test himself at the 22nd Congress of the Communist Party of the Soviet Union, 13 days later. He described the bomb as 50 megatons. He noted it could have been 100. He said the Soviet Union had decided not to use the more powerful version. He did not say the decision was made because the fallout might have poisoned Soviet territory. He did not say the aircraft crew had a 50% survival probability. He did not say the weapon could not be delivered by any existing missile system and had no practical military use. He said only, "We restrained ourselves. The Tsar Bomba had no military value. It was never deployed. It never will be." The single example ever built was used once on a frozen Arctic island to demonstrate a single fact to the watching world. There is no upper limit. That was the message. That was always the message. The Soviet Union had built a weapon whose full power it had deliberately suppressed, not because it could not build the larger version, but because testing the larger version would have been, by the calculations of its own designers, genuinely dangerous to the territory of the nation that built it. Andrei Sakharov understood this more clearly than anyone. He had done the mathematics. He knew what it meant. He spent the rest of his life trying to make sure the mathematics was never applied to a city.